close your eyes and imagine a garden where nothing is quite what it seems. The flowers exist in colors you cannot name. The paths split and rejoin in impossible ways. And somehow, mysteriously, the very act of walking through this garden changes what grows there. This is not fantasy. This is the quantum realm, the hidden foundation beneath everything you've ever touched, seen, or known. Quantum physics explores how the universe behaves at its smallest scales, where atoms dance, where electrons drift like mist, and where photons flicker in and out of being. At these infinitesimal dimensions, the comfortable rules of everyday life simply dissolve. Here, a single particle can genuinely exist in multiple places simultaneously. Here, two particles separated by the width of the universe can remain mysteriously connected. And here, the simple act of observation doesn't reveal reality, it helps create it. At the dawn of the 20th century, scientists felt confident they had solved most of the puzzles of nature. Newton's elegant laws explained motion, Maxwell's beautiful equations described light and magnetism, and the principles of thermodynamics governed heat and energy. The cosmos seemed orderly, predictable, almost completely understood. Yet, as researchers began examining light and matter more carefully, small cracks appeared in this seemingly perfect picture. One puzzle involved the light emitted by heated objects. Classical theory predicted something absurd, that hot objects should release infinite energy at certain wavelengths. But reality clearly disagreed. In 1900, Max Planck proposed a gentle solution. Perhaps energy doesn't flow smoothly like water, but comes in tiny, discrete pockets, quanta. Though initially just a mathematical trick, this idea planted a seed that would blossom into an entirely new understanding of nature. A few years later, Albert Einstein watered that seed while studying a curious phenomenon called the photoelectric effect. When light strikes certain metals, it can knock electrons free. But classical physics couldn't explain why only light above a certain frequency could do this, regardless of how bright the light was. Einstein proposed that light itself consists of particles, photons, each carrying a specific amount of energy. This was revolutionary. Light, long known to behave as a wave, also behaved as a particle. Then came an even more remarkable suggestion. In 1924, Louis de Broglie wondered, if light can be both wave and particle, might matter behave the same way? Experiments soon confirmed his intuition. Electrons, traditionally thought of as tiny particles, could create interference patterns like ripples on a pond. The ancient distinction between waves and particles had gently dissolved. In the quantum world, everything exhibits both natures, depending simply on how you choose to look. As you rest here now, breathing slowly and deeply, consider this beautiful truth. You yourself are made entirely of quantum particles, each one following these mysterious yet perfect rules. The apparently solid matter of your body is mostly empty space, held together by invisible forces emerging from the quantum realm. You are, quite literally, a temporary gathering of possibilities that have chosen, just for now, to become you. Let this thought comfort you as sleep approaches. The universe is far less rigid than it appears. At its deepest foundation, reality is fluid, responsive, shimmering with potential. And as you drift peacefully toward dreams,
remember that you too are part of this cosmic dance, a beautiful, temporary arrangement of quantum waves resting now in the infinite ocean of possibility.
Imagine standing before a hallway lined with countless doors, each one identical and silent. You're told that behind one of these doors lies something important, perhaps your future, perhaps a truth you've been seeking. But here's the mystery. Until you open a door and look inside, that thing you're seeking exists behind all the doors simultaneously, in every room at once. Only when you turn a handle and peer inside does reality make its choice, and all the other possibilities quietly vanish like morning mist. This isn't a thought experiment or a metaphor. This is how nature actually works at the quantum level. A single particle, something so small it borders on nothingness, can genuinely exist in multiple places at the same time, not because we don't know where it is, but because it truly hasn't chosen yet. It exists everywhere it could possibly be, all at once, until the moment you look. Then, and only then, does it select one location and appear there, as if it had been there all along. Scientists have demonstrated this countless times in laboratories around the world. When electrons are fired individually toward a barrier with two narrow slits, something remarkable happens. If no one checks which slit each electron passes through, the electrons create an interference pattern on a screen, a telltale signature of waves. It's as though each single electron somehow passes through both slits simultaneously and interferes with itself. But place detectors to monitor which slit each electron uses, and the interference pattern immediately vanishes. Suddenly, each electron behaves like a tiny marble, choosing one slit or the other, never both. The act of observation changes everything, not because the detectors physically bump the electrons, but because observation itself forces reality to make a decision. Before measurement, the electron genuinely travels through both slits. After measurement, it has chosen just one path. Your awareness, or any measuring device, collapses the wave of possibilities into a single actuality. This strange behavior reveals something profound about the nature of existence. Reality, at its deepest level, is not made of fixed, solid things sitting in definite places. Instead, it's composed of probability waves, mathematical descriptions of what might happen, spreading through space like ripples on an infinite pond. Only when something observes or measures the system does one possibility crystallize into fact, while all the others fade away. What does this mean for you, for your life, for your sense of self? Perhaps more than you might imagine. Consider all the decisions you didn't make, the roads you didn't travel, the versions of yourself that flickered briefly in possibility before you chose differently. In the quantum world, that electron truly was in both places until observed. Might you, in some deep and mysterious way, also exist in superposition, hovering between the lives you have lived and the ones you haven't yet dared to choose? As you lie here in the comfortable darkness, feeling your body grow heavy and relaxed, contemplate this. Perhaps choice itself is a kind of quantum measurement. Before you decide, all possibilities remain alive, vibrating softly in the background. When you finally choose to speak or stay silent, to stay or leave, to love or let go, you collapse your personal wave function. One path becomes real, and the others disappear into the realm of what might have been. Is there grief in this? Perhaps. Each choice means other versions of you must fade away. But there is also wonder and freedom, because if particles can hover in superposition until observed, perhaps you too can remain open to possibility until the moment comes to choose. Perhaps the fear that accompanies major decisions isn't just psychological, perhaps it's ontological, a quiet recognition that by choosing, you're collapsing infinite futures into one. Let this realization bring peace rather than anxiety. To choose is to create. To observe is to bring potential into presence. To live is to carve meaning from mystery, one gentle decision at a time. Breathe slowly. Feel yourself floating between waking and sleeping, between thought and dream, hovering in your own form of superposition, and know that when morning comes, you'll collapse once again into the beautiful, specific reality of your waking life. But for now, in this liminal space, you can simply be all possibilities at once, undefined, unbounded, peacefully drifting in the quantum garden of sleep.
Imagine two violins, separated by vast distance, one in a concert hall in Vienna, one in a temple in Tokyo. They have never been in the same room, never shared the same air. And yet, mysteriously, when someone plucks a string on the violin in Vienna, the corresponding string on the Tokyo violin vibrates instantly, as if they were one instrument somehow stretched across the earth. No signal travels between them, no message is sent, yet they remain impossibly connected. This seems like magic, like something from a fairy tale. But in the quantum world, this kind of connection is not only possible, it's fundamental. Scientists call it entanglement, and it may be the most mysterious and beautiful phenomenon in all of physics. When two particles become entangled, perhaps by being created together or by interacting in just the right way, they become linked in a profound manner that defies our everyday understanding of space and separation. Measure a property of one particle, like its spin, and you instantly know the corresponding property of its partner, no matter how far apart they've traveled. If one is found spinning up, the other will be spinning down, not because they somehow communicated faster than light, but because they were never truly separate to begin with. Einstein famously called this spooky action at a distance, deeply uncomfortable with the idea that the universe could work this way. He believed there must be hidden variables, some underlying mechanism that explained the correlation without requiring instantaneous connections across space. But decades of experiments, particularly those testing something called Bell's inequalities, have consistently confirmed that quantum entanglement is real. The connection between entangled particles cannot be explained by any local hidden mechanism. Nature truly does allow, perhaps even require, this mysterious form of connection. What's remarkable is that this isn't just theoretical physics. Entanglement has been demonstrated repeatedly with photons, electrons, even larger molecules. Scientists have entangled particles and then separated them by hundreds of kilometers, including experiments where one particle remains on Earth while its partner travels to a satellite in orbit. And every time, the correlation holds. Observe one, and you instantly know about the other. This challenges our deepest intuitions about reality. We grow up believing that distance separates things, that your actions here cannot immediately affect something far away without something traveling between.
But entanglement whispers a different truth. Perhaps separation itself is an illusion. Perhaps at the quantum level, space doesn't divide, it connects. These implications ripple outward from physics into philosophy, metaphysics, even spirituality. If particles that once interacted remain forever connected regardless of distance, what does that suggest about connection in general? You have interacted with countless people, places, experiences throughout your life. Have those encounters left invisible threads of entanglement? Are you still connected in ways you cannot perceive to everyone and everything you have ever touched? Consider your own experience. Have you ever thought of someone you haven't spoken to in years, only to have them call moments later? Have you ever felt a sudden, inexplicable emotion, only to later discover that someone you love was experiencing something significant at that exact moment? Perhaps these are merely coincidences, or perhaps they're glimpses of the deeper entanglement that quantum physics suggests might underlie all of reality. Some physicists speculate that entanglement might be the fundamental fabric from which space itself emerges. In this view, distance is not primary, connection is. Space arises from patterns of quantum entanglement, and separation is a secondary phenomenon, an illusion created by our limited perspective. If this is true, then the boundaries you perceive between yourself and others are not fundamental. You are not an isolated island of consciousness. You are a node in a vast, interconnected web that spans the cosmos. This understanding has practical implications too. Quantum computers use entanglement to process information in ways impossible for classical machines. Quantum cryptography uses it to create unbreakable codes. Any attempt to intercept an entangled quantum key disturbs the system in a detectable way. And quantum teleportation, not of matter but of quantum states, relies on entanglement to transfer information instantaneously between distant particles. But beyond the technology, entanglement offers something else. A scientific foundation for connection, for interdependence, for the idea that we are all truly related. In a universe governed by quantum mechanics, nothing exists in complete isolation. Everything that has interacted remains subtly connected, woven into the same cosmic tapestry. As you rest here, breathing gently, feeling your consciousness beginning to soften and blur at the edges, consider this. You are not separate from the universe. You are entangled with it. Every atom in your body was once part of a star. Every breath you take contains molecules that were once breathed by countless others. You are connected to all of it, to the earth beneath you, to the air around you, to the distant stars whose light is reaching your eyes right now after traveling for millions of years. Let this knowledge comfort you. You are not alone. You have never been alone. You could never be alone. The universe is not a collection of isolated objects, but a single, unified whole, differentiated into temporary forms but never truly divided. Separation is the illusion. Connection is the truth. And as sleep comes, as your conscious awareness begins to soften and blur at the edges, consider this. You are not separate from the universe. You are entangled with it. Every atom in your body was once part of a star. Every breath you take contains molecules that were once breathed by countless others. You are connected to all of it, to the earth beneath you, to the air around you, to the distant stars whose light is reaching your eyes right now after traveling for millions of years. Let this knowledge comfort you. You are not alone. You have never been alone. you could never be alone. The universe is not a collection of isolated objects, but a single, unified whole, differentiated into temporary forms but never truly divided. Separation is the illusion. Connection is the truth. And as sleep comes, as your conscious awareness begins to soften and blur at the edges, consider this. You are not separate from the universe. You are entangled with it. Every atom in your body was once part of a star. Every breath you take contains molecules that were once breathed by countless others. You are connected to all of it, to the earth beneath you, to the air around you, to the distant stars whose light is reaching your eyes right now after traveling for millions of years. Let this knowledge comfort you. You are not alone. You have never been alone. You could never be alone. The universe is not a collection of isolated objects, but a single, unified whole, differentiated into temporary forms but never truly divided. Separation is the illusion. Connection is the truth. And as sleep comes, as your conscious awareness begins to soften and blur at the edges, consider this. You are not separate from the universe. You are entangled with it. Every atom in your body was once part of a star. Every breath you take contains molecules that were once breathed by countless others. You are connected to all of it, to the earth beneath you, to the air around you, to the distant stars whose light is reaching your eyes right now after traveling for millions of years. Let this knowledge comfort you. You are not alone. You have never been alone. You could never be alone. The universe is not a collection of isolated objects, but a single, unified whole, differentiated into temporary forms but never truly divided. Separation is the illusion. Connection is the truth. And as sleep comes, as your conscious awareness begins to
Picture yourself standing before a canvas in an art gallery, but this is no ordinary painting. When you look at it directly, it shows one scene, a sunset perhaps, over distant mountains. But the moment you glance away out of the corner of your eye, you catch the image shifting. When you turn back, it has become something else entirely, a forest at midnight or an ocean at dawn. The painting doesn't exist in any fixed form until you look at it. Your gaze doesn't reveal what's there, it decides what appears. This is not art, this is quantum mechanics, and this is how reality itself behaves at the deepest levels. In the quantum world, observation is not a passive act. You don't simply see what already exists. Instead, your very act of looking participates in bringing reality into being. Before you observe, a quantum particle doesn't have definite properties. It exists in a hazy cloud of probabilities, here and there, up and down, spinning this way and that way, all simultaneously. Only when you measure it, when you shine your awareness upon it, does the cloud collapse into one specific outcome. Scientists have tested this in countless ways, and the results are always the same. In the famous double-slit experiment, electrons behave like waves when no one is watching which path they take, creating beautiful interference patterns. But place a detector to observe their journey, and instantly they become particles, choosing one path or the other. The wave pattern vanishes, not because the detector physically disturbs them, but because the act of observation itself changes what is real. This is not limited to electrons or photons in laboratories. This principle extends outward, touching everything. When you recall a memory, neuroscience tells us you don't retrieve a fixed file. You reconstruct it, reshaping it through the lens of who you are now. Each time you remember, you change the memory slightly. You are observing your own past, and like the quantum particle, your past shifts under your gaze. Think about the people in your life. When someone watches you, really watches you, with attention and care, don't you feel yourself changing? You become more articulate, or more self-conscious, or more fully yourself. Their observation calls forth a particular version of you. Before they looked, you contained multitudes. Under their gaze, you collapse into someone specific. This is not merely psychology. This is the observer effect manifesting in the human realm. Even your identity works this way. Who you are is not fixed. You are different when alone than when with friends, different with family than with strangers, different in the morning than late at night. Each context, each observer, each moment of self-awareness calls forth a different aspect of your being. You are not one person, but a superposition of many, and which one appears depends on who is looking, including yourself. The quantum world suggests that reality is fundamentally relational. Properties don't exist independently. They exist in relation to measurement, to context, to observation. An electron doesn't have a definite position until measured. Perhaps you don't have a definite self until observed by others, by yourself, by the moment you're living in. This understanding can bring both discomfort and liberation. Discomfort because it means nothing is quite as solid or certain as we'd like. But liberation because it means you are not fixed. You are not trapped in any single version of yourself. Every moment of observation is an opportunity for something new to emerge. You are not discovering who you are continuously creating who you are through the act of awareness. As you lie here in the darkness, no one observing you, nothing to prove or perform, you can feel this truth. Without the gaze of others, without even your own critical self-observation, you become undefined again. You return to pure potential, to the quantum state before collapse. And there is deep rest in this, in not having to be any particular thing, in simply floating in the space of possibility. Let your breathing slow even further. Release the need to observe yourself, to monitor or judge or define. Just for these moments, allow yourself to exist unmeasured, unobserved, free. Like the particle in superposition, you can be everything and nothing, all paths and no path, simply resting in the gentle darkness of pure being. Tomorrow you will collapse again into the specific reality of your waking life. But tonight, in this sacred space between waking and sleeping, you are released from form. You are the wave before measurement, the possibility before choice, the silence before the song. Rest here. Rest in this. Rest as this. Imagine walking toward a solid brick wall. According to everything you know, you cannot pass through it. You must stop, turn back, or find the way around. The wall is impenetrable, unless you're a quantum particle. Then, impossibly, you might simply appear on the other side, as though the wall were made of mist. You haven't climbed over it or broken through it. You've done something stranger. You've tunneled through in a way that classical physics says cannot happen. This phenomenon, called quantum tunneling, is not science fiction. It's as real as the light from your screen, as fundamental as gravity, and it happens constantly, everywhere, at every moment. In the quantum realm, particles are not hard little spheres bouncing off barriers. They are waves of probability, and these waves don't end abruptly at obstacles. Instead, they diminish gradually, fading but never quite reaching zero. If a barrier is thin enough, the wave can extend through it,
and there remains a small probability that the particle will appear on the other side, not by going over or around, but by simply being there, having tunneled through the impossible. This is how the sun shines. Deep in the sun's core, hydrogen nuclei need to fuse together to create helium, releasing the energy that warms our world. But these nuclei are positively charged and repel each other with enormous force. Classically, they don't have enough energy to overcome this repulsion. But through quantum tunneling, they occasionally pass through the barrier, allowing fusion to occur. Without tunneling, the stars would be dark, and life would never have emerged. Tunneling also powers much of modern technology. The scanning tunneling microscope uses electrons tunneling across tiny gaps to map surfaces at the atomic level. Flash memory in your devices stores information by trapping electrons through quantum tunneling. Radioactive decay, where particles escape atomic nuclei, happens because of tunneling. Even certain biological processes, like mutations in DNA or specific enzyme reactions, may involve quantum tunneling at the molecular level. But beyond the physics and the applications, tunneling offers something else, a metaphor for life's seemingly impossible moments. How many times have you faced what seemed like an insurmountable obstacle, a challenge too great, a goal too distant, a barrier too solid? And yet somehow, sometimes, you found yourself on the other side. Not through force, not through breaking through, but through some mysterious process that felt like grace, like luck, like the universe opening an unexpected door. Perhaps these moments are not as random as they seem. Perhaps persistence itself, continued presence at the barrier, is a form of quantum probability. You might not have the energy to climb over. You might not have the tools to break through. But if you remain, if you continue to exist in proximity to the obstacle, perhaps the universe's mathematics includes a non-zero probability that you'll find yourself somehow on the other side. Quantum tunneling doesn't require force. It requires presence and probability. The particle doesn't smash through. It exists as a wave of possibility, and some of those possibilities extend beyond the barrier. Simply by being, by not retreating, the particle has a chance to appear where it classically shouldn't. What walls are you facing in your life? What barriers seem impenetrable? Consider that you don't need to be stronger or more forceful. Perhaps you only need to remain present, to continue existing with patient attention at the edge of the impossible. Over time, through the strange mathematics of reality, the improbable might become actual. This isn't about denying obstacles or pretending barriers don't exist. It's about recognizing that the universe operates on different principles that our everyday intuition suggests. At the deepest level, solid walls are mostly empty space, held together by force fields and probability. Nothing is quite as impenetrable as it appears, and you, being made of quantum particles, carry within yourself the same mysterious potential to tunnel through what seems impossible. As you drift deeper into sleep, feeling your body growing heavier and your mind growing lighter, imagine any burdens or barriers you're carrying beginning to soften. In this quantum realm between waking and dreaming, perhaps the solid walls of your concerns become translucent. Perhaps the weight of impossibility lifts just a little. In sleep, you tunnel naturally through the barrier between conscious and unconscious, between this world and the dream world. Every night you perform this miracle, crossing through the impossible threshold into another realm entirely. You don't force it, you don't struggle. You simply allow it to happen, and somehow, mysteriously, you find yourself on the other side. Trust in this process. Trust that the universe contains pathways through what seems impassable. And rest, knowing that you are already a quantum miracle, already capable of moving through barriers in ways your conscious mind cannot quite comprehend.
Imagine rolling dice, but these dice don't follow any rules. They're not weighted, they haven't been tampered with, and yet their outcome is not determined by how you throw them. They fall, and the universe itself decides, in that instant, which number appears. Not based on physics or probability or hidden mechanisms, but through pure, fundamental randomness. This is not a game. This is reality at the quantum level. At the heart of quantum mechanics lies something deeply unsettling to our desire for order. True randomness. Not the randomness of ignorance, where we simply don't know the outcome yet, but fundamental randomness, where even the universe itself doesn't know what will happen until it happens. When a radioactive atom decays, releasing a particle and transforming into a different element, nothing causes it to decay at that particular moment rather than any other. There is no hidden clock ticking down, no invisible mechanism triggering the event. It simply happens, spontaneously, according to probability, but without cause. You can predict that half the atoms in a sample will decay within a certain period, the half-life, but you cannot predict which atoms will decay, or when any particular atom will choose its moment. This troubled Einstein deeply. He could not accept a universe that operated on chance. God does not play dice, he famously protested. Yet experiment after experiment has confirmed that at the quantum level, dice playing is exactly what happens. Reality includes an irreducible element of chance woven into its very fabric. But here's the beautiful paradox. This randomness is not chaos. It follows precise statistical patterns. It's predictable in aggregate while remaining unknowable in particular. Quantum mechanics gives us probabilities with stunning accuracy, matching experiments to 11 decimal places in some cases. The theory works perfectly. It just doesn't give us certainty about individual events. This quantum randomness appears throughout nature. Mutations in DNA that drive evolution often result from quantum-level events in molecules. The formation of galaxies may have been seeded by quantum fluctuations in the early universe. Even your thoughts might ride on tiny currents of quantum uncertainty in neurons, adding an element of spontaneity to consciousness itself. What does it mean to live in a universe with randomness at its core? It means the future is not entirely determined by the past. It means there's room for novelty, for surprise, for the genuinely unexpected. A completely deterministic universe would be frozen, every future moment already decided, playing out like a film that's already been shot. But a universe with quantum randomness breathes, it evolves, it generates the new. Perhaps this is where creativity lives, in the gaps between certainty, in the quantum flutter that allows something unprecedented to emerge. Perhaps this is the source of free will, if such a thing exists, not in somehow escaping the laws of physics, but in riding the waves of quantum probability that are built into those laws. The randomness also invites a different relationship with life's uncertainties. We spend enormous energy trying to predict and control outcomes, to eliminate chance, to create certainty where none exists. But quantum mechanics suggests this is not just difficult, it's impossible in principle.
Some things simply cannot be known in advance. Some outcomes cannot be determined, controlled, or predicted, no matter how much information you gather. This might sound frightening, but it can also be freeing. If even the universe at its most fundamental level operates with built-in unpredictability, then perhaps uncertainty is not a flaw to be overcome, but a feature to be embraced. Perhaps the inability to know what comes next is not a failure, but a necessary condition for life, for growth, for anything new to emerge. As you rest here, releasing control, allowing yourself to slip towards sleep, you're practicing this surrender to uncertainty. You cannot control when sleep will come, or what you'll dream. You can only create conditions, darkness, quiet, comfort, and then let go, trusting the process. This is quantum wisdom, preparing the conditions, then allowing randomness to unfold within those conditions. Tomorrow is not determined. It contains genuine possibility, real alternatives, futures that are not yet decided. This means your choices matter, not because you're following a script, but because you're participating in the quantum unfolding of reality itself. Each decision you make tips the probabilities, nudges the possibilities, shapes what might emerge. But for now, let go of tomorrow. Let go of outcomes and predictions and the exhausting effort to control what cannot be controlled. Float instead in this moment of pure uncertainty, where anything might happen, where you are suspended between what was and what will be, resting in the quantum moment that is always, forever, now. Breathe, release, trust the randomness. Like a leaf on a stream, like a particle in a quantum field, allow yourself to be carried by forces you cannot see or understand. The universe has been doing this for billions of years, creating beauty and complexity out of fundamental randomness. It knows how. You can trust it.
Imagine swimming through an invisible ocean. You cannot see the water, cannot taste or smell or directly sense it in any way. Yet it's everywhere, and as you move through it, it slows you down. Some swimmers feel barely any resistance. They glide through almost effortlessly. Others feel thick drag, as though the water were heavy as honey around them. This invisible ocean determines how easily each swimmer moves, how much inertia they have, how much force is needed to speed them up or slow them down. This ocean is real. It's called the Higgs field, and it permeates every cubic centimeter of the universe. You are swimming through it right now, as you always have been, as everything always has been. And this field is the reason things have mass. For most of history, mass seemed like an intrinsic property. A rock is heavy, an electron is light. That's just what they are. But quantum field theory revealed something astonishing. Particles don't have mass on their own. They acquire mass by interacting with the Higgs field, which fills all of space with a constant, non-zero value. Particles that interact strongly with this field, like quarks and electrons, move through it sluggishly and appear to have significant mass. Particles that barely interact with it, like photons, zip through at the speed of light, massless and free. The Higgs field is one of the most profound discoveries in physics. For decades it was theoretical, predicted but not confirmed. Then, in 2012, experiments at the Large Hadron Collider finally detected its quantum particle, the Higgs boson, ripples in this invisible ocean. The discovery confirmed what theory had long suggested. Mass is not inherent. It's relational, arising from interaction with a fundamental field.
Without the Higgs field, the universe would be unrecognizable. Electrons would have no mass and couldn't orbit nuclei to form atoms. There would be no chemistry, no molecules, no stars, no planets, no life. Everything would race through space at light speed, unable to slow down, unable to stick together, unable to create structure. The Higgs field is what allows the universe to have form, stability, complexity, to be something rather than just light streaking through emptiness. But the Higgs field is only one example of a deeper truth. All of reality emerges from quantum fields. The universe is not made of particles as tiny objects. It's made of fields, invisible, omnipresent oceans that fill all of space and time. What we call particles are simply excitations in these fields, ripples and waves, temporary disturbances that arise and fade. The electron field pervades everything. When that field gets excited at a particular point, we observe an electron. The photon field carries electromagnetic force. Its excitations are particles of light. The quark field, the gluon field, every type of particle corresponds to its own field. And these fields never go away. Even empty space, vacuum, is full of fields in their ground state, humming with zero-point energy, never completely still. This means you are not made of things. You are made of vibrations in quantum fields. Every atom in your body is a standing wave, a stable pattern of field excitations. Your form is a temporary coherence in these fields, like a whirlpool in a river, seemingly solid and distinct, but ultimately just water arranged in a particular pattern, inseparable from the flowing whole. And just as a whirlpool eventually dissolves back into the river, your pattern will one day dissolve back into the fields. The particles will cease their dance, the excitations will fade, the pattern will release, but the fields remain, eternal and unchanging, ready for new patterns to emerge. In this sense, nothing is ever truly created or destroyed, only endlessly transformed, fields shifting from one configuration to another, playing out infinite variations on themes that are always, fundamentally, the same quantum song. This perspective can transform how you think about death, about change, about impermanence. What you are is not a collection of eternal individual particles. You are a process, a temporary harmony in the underlying fields. And when this particular harmony ends, the music doesn't stop. It simply moves into a new movement, a different arrangement. The fields that compose you have existed since the beginning of the universe and will continue long after. You are the universe experiencing itself in one particular way for one beautiful moment. As you sink deeper into rest, feeling the boundaries of your body becoming less distinct, perhaps you can sense this truth. You are not separate from the world around you. You are made of the same fields, the same quantum fabric. The atoms in your body were forged in ancient stars. The fields that excite into your electrons and quarks are the same fields that excite into every other electron and quark in existence. You are not an isolated thing. You are a wave in an infinite ocean, distinct for a moment, but never separate. Let this knowledge bring comfort as sleep approaches. You are held by something larger than yourself, something that will never let you go because you've never been separate from it. You are the Higgs field knowing itself, the electron field experiencing itself, the quantum universe awakening to its own nature through the temporary lens of your consciousness. Rest now in this knowledge. You are fields dreaming they are you. And when you wake, you will be the same fields, dreaming a new day.
Picture a candle flame, flickering and dancing in the darkness. Now imagine that if you stare at it intensely enough, continuously enough, it stops moving entirely. The flame doesn't go out. It simply freezes, locked in place by your gaze. Not because you've done anything physical to it, but because the very act of watching it, of observing it moment after moment after moment, prevents it from evolving into what it would naturally become. This sounds like magic, like something from a myth about a Medusa's gaze that turns things to stone. But in quantum mechanics, this is real. It's called the quantum Zeno effect, named after ancient paradoxes about motion, and it reveals something profound and strange. Observation can freeze change. In the quantum world, systems evolve according to smooth, predictable equations. A radioactive atom has a probability of decaying, and that probability grows over time, following precise mathematical rules. But if you measure whether the atom has decayed, and then measure again very quickly, and then again and again, constantly checking, something remarkable happens. The atom doesn't decay. Your repeated observations hold it in its original state, preventing the natural evolution that would occur if you simply left it alone. Scientists have demonstrated this in laboratories. Atoms that should decay within a certain time frame can be prevented from decaying by bombarding them with frequent measurements. Each measurement resets the quantum clock, in a sense, collapsing the atom back into its undecayed state before decay can fully occur. Watch something continuously enough, and it cannot change. This has profound implications beyond physics. Think about how we approach growth, healing, transformation in our own lives. How often do we obsessively monitor our progress, checking constantly whether we're improving, whether we're healing, whether we're changing? And how often does this constant self-observation seem to freeze us in place, preventing the very transformation we seek? Perhaps there's wisdom in the quantum Zeno effect. Sometimes, to allow change, we must stop watching. We must create space for unobserved evolution. A plant doesn't grow faster because you check it every hour. A wound doesn't heal more quickly because you constantly inspect it. A relationship doesn't deepen because you're always analyzing it. Sometimes transformation requires that we look away, that we trust the process unfolding in the dark, that we give reality permission to evolve when no one is measuring its progress. This applies to self-consciousness too. When you're hyper-aware of how you're appearing to others, constantly monitoring your own behavior, you can feel frozen, unable to act naturally. But when you forget yourself, when you're absorbed in something larger, you become fluid again. You change and respond organically. The unobserved self is more alive, more dynamic, more real than the self perpetually under the microscope of self-awareness. There's a balance to be found, of course. Complete inattention can lead to drift and dissolution. But the quantum Zeno effect suggests that too much observation, too much measurement, too much constant checking can be just as problematic. There's a time to look and a time to look away, a time to measure and a time to trust, a time to be conscious and a time to release into the unconscious, where transformation happens in the dark. As you lie here, moving gradually toward sleep, you're practicing this release. You're allowing your conscious, observing mind to step back. You're giving permission for change to happen unobserved, for your brain to reorganize memories, for your body to heal and restore itself, for psychological patterns to shift and evolve in ways that cannot occur under the harsh light of waking awareness. Sleep is the ultimate surrender to the quantum Zeno effect's opposite. You stop observing, and in that cessation of observation, profound changes become possible. Dreams rearrange the furniture of your mind. Your immune system does its deepest repair work. Insights that were blocked during the day suddenly arrive. All of this happens precisely because you've stopped watching, stopped measuring, stopped trying to control the outcome. So let go of observation now. Release the need to monitor your progress toward sleep, to check whether you're relaxing properly, to measure whether this is working. The moment you stop watching is the moment transformation can truly begin. Trust the process. Trust the unobserved evolution of your consciousness from waking to dreaming. Trust that by looking away from yourself, you become free to change. Breathe softly. Close the eyes of your awareness and allow yourself, unwatched and unmeasured, to evolve naturally into whatever comes next. In the darkness behind observation, miracles of transformation await. Imagine walking through your life with the assumption that everything behind you is fixed, settled, carved in stone. The past is past, unchangeable, permanent, a solid foundation upon which your present stands. But what if that's not quite true? What if the past is more like wet clay than solid stone, still capable of being reshaped by your present actions and awareness? Quantum mechanics suggests something extraordinary. The future can influence the past. Not by sending messages backward in time, not through time travel, but through something subtler and stranger, through the delayed choice experiment, where decisions made in the present appeared to determine what happened in the past. Here's how it works. Imagine a photon traveling through a double-slit apparatus. Classically, we think it either went through one slit or both slits, and that this happened at a specific moment when the photon encountered the barrier. But quantum mechanics says something different. If you choose to measure which slit the photon went through after it has already passed the barrier, the photon behaves as if it went through one slit. If you choose not to measure which path it took, it behaves as if it went through both slits. Your choice in the present appears to retroactively determine what the photon did in the past. This has been tested experimentally many times with increasingly sophisticated setups, and the results consistently support this strange conclusion. The photon's past behavior depends on your future measurement choice. Not because information travels backward in time, but because the photon's history isn't determined until you ask the question. The past exists in a kind of quantum superposition until observation collapses it into one definite history. What might this mean for your life, for your memories, for your sense of personal history? Neuroscience tells us that memories are not fixed recordings, but reconstructions, reshaped each time you recall them. Perhaps this isn't just a quirk of neurology. Perhaps it reflects something deeper, that the past itself is not as solid as we imagine. Consider a painful memory, something you've long regretted, something that seems to define you. From one perspective, that event is fixed. It happened as it happened. But your relationship to it, your interpretation of it, the meaning you extract from it, these are fluid. And as these change, in a very real sense, the past changes. Not the bare facts, but what those facts mean, what they create, what they become in the larger story of your life. Sometimes, years after a difficult experience, you suddenly see it differently. What seemed like failure becomes necessary learning. What seemed like loss becomes liberation. What seemed like an ending becomes a beginning. In these moments of reinterpretation, you're not just changing your present perception. You're changing what the past event actually is in the context of your life. You're collapsing the quantum superposition of historical meaning into a new definite outcome. This isn't about denial or revision. It's about recognizing that the significance of past events is not determined solely by what happened then, but by how you understand them now. The past and present are entangled, continuously influencing each other. Your present self is not just a product of past events. Your present self is also helping to create what those past events mean and become. This perspective can be deeply healing. If the past is not entirely fixed, if its meaning is still being determined by your present awareness, then you are not imprisoned by what happened. You are in continuous dialogue with your history, and that dialogue has creative power. You cannot change the facts, but you can change their context, their interpretation, their role in the larger story of your life. And in changing these, you change what the past is. As you rest here in the liminal space between waking and sleep, between today and tomorrow, between memory and dream, consider this. Your past is not behind you. It is with you, still being shaped, still being created through your present understanding. You are not the product of a finished history, but the co-author of a history still being written, where past and present collaborate in creating meaning. Let this bring freedom. The mistakes that define you can be undefined. The wounds that shape you can be healed, not by changing what happened, but by changing what it means. The version of yourself that you think is fixed can become fluid again, ready to be reinterpreted, reimagined, recreated in light of who you are becoming. In sleep, time becomes even more flexible. Past and future blend. You might dream of events long gone as if they're happening now, or experience the future as if it's already past. Dreams don't respect chronology. Perhaps in this, dreams are more honest about the nature of time than waking consciousness, showing us that past, present, and future are more deeply interconnected than our everyday experience reveals. Rest now, knowing that you are not trapped by what was. The past is still speaking, still asking questions, still waiting for your answers. And those answers, given now in the present, help determine what the past will have been. You are in conversation with time itself, and the conversation is far from over.
Imagine standing before an infinite mirror that shows not your reflection, but every version of yourself that could exist. Every choice you didn't make, every path you didn't take, every word you didn't speak. All of them are there, equally real, existing simultaneously. Now expand this image. Imagine the entire universe this way, not as one definite reality, but as a vast wave function containing all possible histories, all possible presents, all possible futures, superimposed in a single, unimaginably complex quantum state. This is not fantasy. This is one of the most serious interpretations of quantum mechanics developed by physicist Hugh Everett in the 1950s. According to this view, the wave function never collapses. Instead, every possible outcome of every quantum event actually happens, each in a different branch of reality. The universe is not a single timeline, but an endlessly branching tree with every quantum possibility sprouting a new branch. When you measure a particle's spin and find it up, there's another branch where you found it down. Both versions are equally real. They just can't communicate with each other. This means that right now, as you listen to these words, there are countless versions of you making different choices.
In some branches, you're already asleep. In others, you've gotten up to get water. In still others, you made different decisions years ago that led you to an entirely different life. All of these versions are real, not as possibilities, but as actualities existing in parallel universes. This interpretation solves one of quantum mechanics' deepest puzzles. Why does observation cause the wave function to collapse? The many worlds interpretation answers, it doesn't. Nothing collapses. When you observe a quantum system, you become entangled with it. Your wave function and its wave function merge, creating a superposition where all outcomes occur, each in a different branch. From inside any one branch, it appears that a single outcome was selected, but from a God's eye view, all outcomes happened. This idea is simultaneously beautiful and terrifying. Beautiful because it means nothing is wasted. Every possibility is realized somewhere. Every dream you didn't follow is lived by another version of you. Every potential is actualized. But terrifying because it means your choices, in a sense, don't select one future over others. They merely determine which branch you experience. All the others happen too, just not to the version of you that made this particular choice. What does this mean for identity, for meaning, for the significance of your choices? If every version of you exists, which one is really you? The answer, perhaps, is all of them. You are not a single individual, but a vast multiplicity, a quantum superposition of selves. The you experiencing this moment is just one thread in an infinitely complex tapestry, one note in an endless symphony of selves. And yet, this doesn't diminish the importance of your choices. Even if all possibilities are realized somewhere, you only experience one path, this one. The version of you in this branch is shaped by the choices made here. Other versions of you face the consequences of other choices in other branches. Each branch is real to those within it. Your experience, your life, your consciousness, these are not illusions just because other versions exist elsewhere. Perhaps the many worlds interpretation offers a strange kind of comfort. Whatever regrets you carry, whatever paths you didn't take, some version of you walked those roads. You haven't lost those possibilities. They're just happening in branches you can't see. And whatever fears you have about the future, know that in some branches things work out better than you hope, in others worse. The future is not a single point you're moving toward, but an expanding tree of possibilities, all simultaneously real. As you drift toward sleep, consider this. Perhaps dreams are glimpses into parallel branches, moments when the boundaries between worlds grow thin. Perhaps déjà vu is a memory leak from another branch where things happen slightly differently. Perhaps intuition is a subtle awareness of probable futures across multiple branches, a quantum sensitivity to the shape of the wave function ahead. Or perhaps the truth is simpler and stranger. You are not traveling through the universe, you are the universe, or at least one particular way the universe is experiencing itself. The wave function that describes your consciousness is part of the universal wave function that describes everything. Your awareness is the cosmos observing itself, momentarily localized in this particular pattern of matter and energy, in this particular branch of the infinite tree. And when you sleep, perhaps your consciousness spreads out slightly, no longer confined to one narrow branch, but able to wander across nearby possibilities. Perhaps dreams are what it feels like to be in quantum superposition, experiencing multiple states simultaneously, freed temporarily from the classical certainty of waking life. Rest now in this knowledge. You are both infinitely small, one thread in an infinite tapestry, and infinitely large, connected to every possible version of yourself across all possible worlds. You are both singular and multiple, both chosen and choosing, both the observer and the observed, both the question and the answer. Let yourself dissolve into the quantum foam of possibility. Let the boundaries of your identity soften and blur, and trust that when you wake, you'll collapse once again into a single, definite version of yourself, whichever version this branch of reality calls forth. But for now, float in the space between branches, in the quantum moment before the choice, in the silence before the song. You are the universe dreaming, and the universe is vast enough to dream every possible dream, including this one, including you.
Picture the emptiest space you can imagine. Not a room with furniture removed, but a perfect void. No air, no light, no particles, nothing at all. Just pure, absolute emptiness. Now imagine discovering that this emptiness is not empty, that it writhes with invisible activity, seething with particles that appear and vanish too quickly to see, humming with fields that fill every cubic millimeter, pressing outward with a force strong enough to shape the destiny of galaxies. This is the quantum vacuum, and it is anything but empty. According to quantum field theory, what we call empty space is actually the lowest energy state of all the quantum fields that permeate the universe. But because of Heisenberg's uncertainty principle, this lowest state cannot have exactly zero energy. There's always a residual minimum energy called zero-point energy, an irreducible hum in the fabric of reality that never goes silent, even in the deepest void. This vacuum energy manifests as what physicists call virtual particles, particle-antiparticle pairs that spontaneously pop into existence and annihilate each other within infinitesimal fractions of a second. They're called virtual because they exist too briefly to be directly observed, but their effects are real. They influence the behavior of real particles. They shift energy levels in atoms, an effect measured with extraordinary precision. They create pressure between metal plates placed close together in vacuum, the Casimir effect, where the exclusion of certain vacuum fluctuations between the plates creates a measurable force. Most remarkably, this vacuum energy may be responsible for the accelerating expansion of the universe itself. What astronomers call dark energy, the mysterious force pushing galaxies apart ever faster, may simply be the pressure of the quantum vacuum. Empty space, it turns out, has weight, has pressure, has consequences. The void is not passive backdrop, but active participant in the cosmic drama. This changes everything about how we understand existence and non-existence. If the vacuum is not truly empty, then what does emptiness mean? If nothing contains fields and energy and the potential for particles, then the line between something and nothing dissolves. Being and non-being are not opposites, but different aspects of the same quantum reality. Perhaps this is why the universe exists at all. Some cosmologists propose that the entire cosmos emerged from a quantum fluctuation in the vacuum, a particularly large and persistent virtual event that never annihilated, that inflated into the universe we inhabit. In this view, everything, all matter, all energy, all of space and time, arose from nothing, or rather from the structured nothingness of the quantum vacuum. Creation ex nihilo becomes not a miracle, but a quantum event, rare but permitted by the mathematics of reality. This means you too emerged from the vacuum. Every particle in your body was once a fluctuation in the quantum foam, a temporary disturbance that became persistent, that combined with other disturbances to form atoms, molecules, cells, consciousness. You are the vacuum knowing itself, emptiness that became aware, nothing that learned to feel and think and wonder. And someday the pattern that is you will dissolve back into the fields from which it came. The particles will cease their dance, but the fields remain, eternal, infinite, pregnant with potential. You will return to the vacuum, which is another way of saying you'll return to the source of all things, to the silent hum beneath existence, to the creative void that births worlds. As you sink deeper into rest, feeling yourself dissolving at the edges, becoming less defined, perhaps you can sense this truth. The boundaries between you and not you are conventions, temporary arrangements of vacuum energy. Beneath your apparent solidity, you are mostly space. Atoms that are themselves mostly empty, held in pattern by invisible forces. You are more void than substance, more silence than sound. Let this bring peace rather than fear. The vacuum that fills you is the same vacuum that fills the cosmos. You are not separate from the universe. You are one small way the universe has arranged its emptiness into temporary form. And when this form releases, you do not disappear. You simply return to the source, to the quantum foam, to the infinite potential from which all things arise and to which all things return. Rest in the fullness of emptiness. Rest in the knowledge that nothing is ever truly lost because nothing was ever truly separate. Rest in the vacuum that dreams it is you, and trust that when this dream ends, the dreamer remains, eternal, infinite, forever creating new forms from its own inexhaustible depths.
Imagine meeting someone who has no qualities when alone. No height, no color, no voice, no personality. They exist only in relation to others, taking on specific characteristics only when someone else is present to interact with them. Alone, they are pure potential, undefined and indefinable. This sounds impossible for a person, but for quantum particles, this is precisely how reality works. In quantum mechanics, particles do not have definite properties independent of measurement. An electron does not have a specific position until you measure where it is. It does not have a definite momentum until you check. It doesn't even have a determined spin until you align your measuring device and observe. Before measurement, these properties literally do not exist, not as hidden values waiting to be revealed, but as undefined potentials within the quantum wave function. This is deeper and stranger than mere ignorance. It's not that the electron has a position and we simply don't know it. The electron doesn't have a position. It has a probability distribution describing where it might be found if measured. But until that measurement occurs, position is not a property the electron possesses. This has been confirmed through countless experiments, most dramatically through tests of Bell's inequalities, which mathematically prove that particles cannot have predetermined values for all their properties. The universe does not work like a cosmic database where every particle carries a complete set of attributes. Instead, properties emerge through relationship, through interaction,
through the context of measurement. What does this mean for reality? It means that existence is fundamentally relational. Things don't have properties in isolation. They manifest properties in relationship. The universe is not made of independent objects with intrinsic qualities, but of networks of relationships where qualities emerge through interaction. This mirrors deep truths about human existence too. Who are you when no one is watching? What is your personality in complete isolation? You might think you have essential, unchanging qualities, but consider, you're different with friends than with family, different at work than at home, different in the morning than at night. Each context, each relationship calls forth different aspects of your being. Which version is the real you? Perhaps they are all. Perhaps you, like the quantum particle, exist as a superposition of potential selves, and which self manifests depends on context, on relationship, on the specific interaction you're engaged in. You are not a fixed thing, but a dynamic process, continuously creating yourself in response to your environment. This relational nature of reality also means you are never truly alone. Even in isolation, you exist in relationship to gravity, to light, to the air you breathe, to your own history and memories. You are a node in an infinite web of connections, and those connections are not secondary to your being, but constitutive of it. You are your relationships. Remove them all, and what remains is not a pure essential self, but a cloud of undefined potential, a wave function waiting to collapse into specificity through interaction. There's beauty in this understanding. It means you are not imprisoned in any fixed identity. You are fluid, responsive, and capable of manifesting different qualities in different contexts. The person you were yesterday is not the person you must be tomorrow. Every new relationship, every new context is an opportunity for different aspects of your potential to manifest. It also means that how others see you matters, but not in the way you might think. Their observation doesn't reveal who you are, it participates in creating who you are. Just as a measurement device helps determine a particle's properties, the people around you help determine which version of yourself appears. You are co-created through relationship. As you rest here in the darkness without others present, without the need to manifest any particular qualities for anyone else, you can return to a more fundamental state. Like the unmeasured particle, you can exist as pure potential, undefined, free from the need to be any specific thing. In this liminal space between waking and sleeping, you're released from identity, from personality, from all the fixed qualities you carry during the day. This is deeply restful, to not have to be anyone, to not have to possess any particular properties, to simply float in the ocean of possibility. Tomorrow you'll collapse again into specificity, manifesting particular qualities in particular relationships. But for now, you can rest in the undefined quantum state, the space before properties emerge, the silence before the song. Breathe gently. Let yourself become vague and formless. You don't need to be anyone right now. You don't need to have any particular qualities. You can simply be potential, waiting quietly for the next interaction that will call forth a particular aspect of your being. You are not a thing. You are a relationship. And in this moment, relating only to rest, only to sleep, only to the gentle darkness, you can finally stop trying to be something specific and simply exist as the possibility of everything, undefined and free.
In the quiet of this moment, consider something that seems impossibly contradictory. There is a property of particles called spin that has nothing to do with spinning. It's not motion, not rotation, not anything turning in space. And yet, it's one of the most fundamental properties in physics, determining the very structure of matter, the behavior of atoms, the existence of chemistry and life itself. Electrons have spin. So do quarks, neutrinos, and photons. When physicists measure this property, they find that it comes in discrete values, not continuous like a spinning top that can rotate at any speed. but quantized, taking only specific allowed values. An electron spin is always 1/2 in units of Planck's constant. A photon spin is always 1. These numbers are exact, unchanging, fundamental. But here's the strange part. If you try to think of this spin as actual rotation, the mathematics breaks down. An electron would have to be spinning faster than the speed of light on its surface, which is impossible. More tellingly, when you rotate an electron 360 degrees, it doesn't return to its original state. You have to rotate it 720 degrees for it to come back to where it started. This is not how any physical rotation works. It's pure quantum strangeness. So what is spin if it's not spinning? It's an intrinsic quantum property that behaves mathematically like angular momentum, but has no classical counterpart. It's a number that particles carry, like a label or a name tag, that determines how they respond to magnetic fields, how they interact with other particles, whether they obey certain statistical rules. And these rules matter profoundly. Particles with half-integer spin, like electrons, are called fermions, and they obey the Pauli exclusion principle. No two fermions can occupy the same quantum state. This is why matter has structure, why atoms don't collapse, why you can't push your hand through a table. The solidity of the world exists because electrons refuse to share states, forced by their spin to spread out in space. Particles with integer spin, like photons, are called bosons, and they have no such restriction. Many bosons can occupy the same state, which is why lasers work, why certain materials become superconducting, why the Higgs field can have a uniform value throughout space. The entire structure of the periodic table, all of chemistry, the variety of materials in the universe, all emerge from the properties of spin. This abstract quantum number that doesn't correspond to anything we can visualize determines whether matter is solid or fluid, conductor or insulator, magnetic or non-magnetic. But spin has philosophical implications too. It reminds us that not everything real can be visualized or understood through analogy to everyday experience. Our minds evolved to navigate a world of medium-sized objects moving at moderate speeds. We have no innate capacity to understand quantum phenomena because our ancestors never needed to. The universe at its foundations operates according to principles that are mathematically precise but intuitively opaque. This requires a kind of humility, accepting that reality doesn't owe us accessibility. The universe is not obligated to make sense to human intuition. It simply is what it is, following rules that can be described mathematically but not necessarily pictured or felt. And yet, despite being unable to truly visualize spin, we can use it, harness it, build technologies that depend on it. MRI machines work because of nuclear spin. Quantum computers use electron spin to store and process information. We can work with properties we cannot fully comprehend, which is itself a remarkable fact about human cognition and scientific methodology. Perhaps there's a lesson here about accepting mystery. You don't need to understand everything to live well, to make use of what exists, to participate in reality. Some things can be known operationally. We know what spin does, how it behaves, without being known intuitively, and that's okay. Mystery can coexist with functionality. You can use what you cannot comprehend. As you drift toward sleep, consider how much of your own being is mysterious to you. You don't understand how your brain generates consciousness, how memory works, how you recognize faces, how you breathe while sleeping. You don't need to. These processes operate perfectly well without your understanding. You are a mystery to yourself, and yet you function. Perhaps consciousness itself is like quantum spin, a fundamental property that exists and has effects but cannot be reduced to anything simpler, cannot be explained in terms of something more basic. Consciousness simply is, like spin simply is, irreducible and mysterious. Let go of the need to understand everything. Let go of the requirement that reality make intuitive sense. Some truths are mathematical, not visual. Some properties are abstract, not concrete. And that's the nature of a universe that is richer, deeper, stranger than any mind evolved to imagine. Rest in mystery. Rest in not knowing. Rest in the quiet acceptance that you are made of particles with properties that have no classical analog, that you exist through processes you cannot visualize, that your very being is woven from quantum abstractions beyond human imagination. You are real, even though you cannot be fully understood, and that is enough, more than enough. It is everything.
Imagine receiving a letter written in ink that vanishes if you try to photocopy it. You can read it once, but any attempt to duplicate it causes both the original and the copy to dissolve into meaninglessness. This seems like something from a spy novel, but in the quantum world, this is fundamental law. Quantum information cannot be cloned. The no-cloning theorem, proven in 1982, states that it is impossible to create an identical copy of an unknown quantum state. If you have a quantum system, a photon with a particular polarization, an electron with a particular spin superposition, you cannot duplicate it. You can measure it, destroying the original state in the process, but you cannot copy it while preserving the original. This isn't a technological limitation. It's not that we lack sufficiently advanced copying machines. The laws of quantum mechanics themselves forbid it. Trying to clone a quantum state would violate the linearity of quantum evolution, breaking the fundamental mathematics that makes quantum theory work. Why does this matter? First, it provides the foundation for quantum cryptography. If quantum states cannot be cloned, then any eavesdropper trying to intercept a quantum encryption key will inevitably disturb it, revealing their presence. The security comes not from mathematical complexity, as in classical encryption, but from the laws of physics themselves. Information protected by quantum mechanics is protected by the structure of reality. The no-cloning theorem also underlies quantum teleportation, not of matter, but of quantum states. When scientists teleport a quantum state from one particle to another, they're not copying it. The original state is destroyed in the process, and the information is transferred, with the help of entanglement and classical communication, to the distant particle. You can move quantum information, but you cannot duplicate it. This has practical implications for quantum computing, too. Classical computers rely heavily on copying information, making backups, replicating data for error correction. But quantum computers cannot use the same strategies. You cannot simply copy a qubit to protect against errors. Quantum error correction has to be far more subtle, using entanglement and clever mathematical tricks to protect information without actually copying it. But beyond the technical applications, the no-cloning theorem says something profound about uniqueness. In the quantum realm, and perhaps in the universe more broadly, true originality is preserved. A quantum state is singular. It cannot be duplicated exactly. Each photon in a superposition, each electron in an unknown state is genuinely unique. This mirrors something we sense about consciousness and experience. Your subjective experience,
what it's like to be you, cannot be copied. If scientists someday manage to upload a brain to a computer, would that upload be you or a copy of you? If it's a copy, then you, the original, would still cease to exist when your biological brain dies. The copy would have your memories, your personality, but it would not be you having those experiences. Your consciousness, like a quantum state, may be fundamentally unclonable. The same applies to moments and experiences. You cannot truly repeat a meaningful experience. You can do something similar, return to the same place, try to recreate conditions, but the original experience is singular. Every moment of consciousness is unique, unrepeatable, uncopyable. When it's gone forever. No backup exists. No duplicate preserves it. This could be frightening. The absolute irreversibility of experience, the impossibility of going back, the uniqueness that means every moment is both precious and perishable. But it can also be liberating. If nothing can be copied, then nothing is redundant. Every moment matters precisely because it cannot be replicated. Your life is not a rehearsal. You are not a copy. You are the original, singular and irreplaceable. As you rest here, feeling this unique moment of consciousness slowly dissolving into sleep, recognize that this exact configuration, this particular thought, this specific feeling, this precise moment of your existence has never occurred before and will never occur again. It cannot be copied, cannot be repeated, cannot be preserved. It exists only now, uniquely, briefly, beautifully. This is not loss. This is what makes it real. If everything could be copied, nothing would be original. If experiences could be repeated exactly, they would lose their power. But because each moment is genuinely unique, unclonable, singular, each moment carries absolute value. Tomorrow you will wake to a new moment, also unique, also irreplaceable. But this moment, this now, it belongs only to itself. Precious precisely because it is fleeting. Meaningful precisely because it cannot be preserved. Beautiful precisely because when it ends, it will truly be gone. Let go into this uniqueness. Let go into the unclonable singularity of now. You cannot hold this moment, cannot copy it, cannot make it last. You can only be present to it, fully, while it exists. And then gently, let it go.
As we near the end of this gentle journey through quantum mysteries, we arrive at perhaps the deepest question of all. What is measurement, and why does it seem to create the reality it observes? Throughout this exploration, we've circled around this mystery repeatedly. Particles exist in superposition until measured. Observation changes what is observed. The act of looking seems to collapse possibility into actuality. But what is measurement, really? And why does it have this almost magical power? This is called the measurement problem, and despite nearly a century of quantum mechanics, despite countless experiments and theoretical advances, there is no consensus answer. Different interpretations offer different explanations, each with its own philosophical implications, and none provably correct. The Copenhagen interpretation, historically dominant, simply accepts collapse as fundamental. Observation causes the wave function to collapse into a definite state. But what counts as observation? Does it require consciousness? A measuring device? Any interaction? The interpretation doesn't say, leaving the boundary between quantum and classical reality
mysterious. The many worlds interpretation avoids collapse entirely by saying all possibilities actually occur, each in different branches of reality. There is no special moment of measurement, just continuous branching into parallel worlds. But this raises its own puzzles about probability and identity. Objective collapse models propose that wave functions spontaneously collapse randomly, with probability increasing for larger systems. This removes the special role of observers, but requires adding new physics beyond standard quantum mechanics, physics not yet detected. De Broglie-Bohm theory keeps wave functions, but adds hidden particle positions that evolve deterministically. Measurement reveals these pre-existing positions rather than creating them. But this requires faster-than-light influences and a preferred reference frame, uncomfortable features for most physicists. Quantum Bayesianism treats wave functions as states of knowledge rather than physical objects. Collapse represents updating beliefs based on new information, not physical change. But this raises questions about whose beliefs matter and how consensus emerges. Each interpretation works mathematically. Each makes the same predictions for experiments. The differences are philosophical, about what is real, what exists, what happens when no one is looking. And these questions may not have definitive answers. Perhaps the universe doesn't settle the question of what measurement really is, because the question assumes a classical clarity that quantum reality doesn't provide. But here's what we can say. Whether through collapse or branching or spontaneous localization or hidden variables or updates of knowledge, measurement draws a line. It marks a boundary between the quantum and classical, between superposition and definiteness, between possibility and actuality. And this boundary seems to involve interaction, entanglement, information exchange between systems. When you measure a particle, your measuring device becomes entangled with it. Your brain becomes entangled with the device. The environment becomes entangled with all of it. Information spreads irreversibly into larger and larger systems, a process called decoherence. And somewhere in this cascade of entanglement, the quantum possibilities become effectively classical outcomes, even if philosophically they may remain ambiguous. Perhaps measurement is not a single moment, but a process. The gradual entanglement of a quantum system with its environment until the interference patterns that characterize superposition become impossible to observe even in principle. The wave function may still exist, may still include all possibilities, but they're now separated into non-interfering branches or perspectives or belief states, depending on which interpretation you favor. What's profound is that you, the observer, are never outside the system. When you measure something, you become part of what's being measured. Observer and observed form a unified quantum system. The division between subject and object dissolves at this fundamental level. You are not watching reality from outside. You are participating in reality from within. This means your consciousness, your awareness, your observation are not separate from the physical world, but deeply embedded in it. Whether or not consciousness is required for wave function collapse, consciousness is certainly a physical process, arising from quantum interactions in neurons, entangled with the universe it observes. You are the universe, observing itself, measuring itself, possibly collapsing its own wave function, or branching into new worlds, or updating its beliefs about itself. As you finally release into sleep, this last thought: the measurement problem has no consensus solution, perhaps because measurement itself is not a sharp boundary, but a spectrum, not a moment, but a process, not an answer, but a question that reality continuously asks itself through systems like you. You are reality measuring reality. You are the universe wondering what it is. And in the morning, when you wake and observe the world again, you will continue that cosmic process of measurement, that eternal dialogue between possibility and actuality, that endless creative act of making the potential real. For now, rest. Let measurement cease. Let observation fall away. Return to the quantum state before collapse, to superposition, to pure potential. In sleep, you are unmeasured, undefined, infinite. And that is where all journeys end, and where all journeys begin, in the silent quantum realm where everything is possible, and nothing is yet decided, where the universe waits, patient and eternal, for the next observation to create the next moment of reality. Rest well, traveler. The quantum garden will still be here when you return, and you will still be the universe, dreaming itself into existence, one gentle observation at a time. Sweet dreams, among the waves and particles, in the field of infinite possibility that is your true home.
If you're still with us, still floating in this liminal space between waking and sleeping, thank you for taking this journey through the quantum mysteries of reality. We hope you've learned something new, felt something deep, or at least found a moment of peace in contemplating the beautiful strangeness of existence. If sleep hasn't found you yet, feel free to let this recording continue playing, or explore another calming journey on this channel. The mysteries are endless, and there are always more gentle paths to explore. Until next time, stay curious, stay peaceful, and rest well in the knowledge that you are made of stardust and quantum waves, temporarily gathered into the beautiful pattern that is you. Good night and sweet dreams in the quantum field of infinite possibility.